So here we are now, and when we will start our application, we still get that error, which is saying, hey, passenger requires a primary key, right? And if you know SQL or SQL, you will know that a primary key is a way to identify an object inside of a table, right? So primary key is a unique key. Now, if we take a look at our passenger right now, you can see that we don't have a unique key. So we don't have an ID, for example, but an email address could potentially be used as a primary key because we expect that a passenger always enters his own email address, and an email address can only exist once. Instead of adding an ID and changing the entire system, we will now take a look at an override method, which is called onModelCreating, where we can in the end specify that we want the email field here of the passenger to be the primary key. As you may have noticed, this challenge here is definitely some more advanced stuff. So you want to get the most detailed information that we can provide you. Let's now switch over to our entities class that we got right here. So this is our DB context, which gets called when we create the application. And here, as I said, we can override a specific method, which is called onModelCreating. So let's do that. It's called protected override void onModelCreating. Now this takes the model builder called model builder. There we go. And inside here, we can now, for example, go ahead, call the model builder, say entity of type passenger, goes ahead, it has a key, right? So you can read it here, set the property that make up the primary key for this entity type. So we set the primary key to be passenger goes to passenger.email. We set for every passenger the email to be the primary key. Now, at this point, I want to mention something else. When we go to the passenger here, you can still see that this is a record. Why did we change the flight that we have here to be a class, which is stored inside of the database? But you can also see that passengers are stored in a database because we set them to dbSet, right? So why is passenger a record, and why did we need to change the flight to be a class instead? So the difference is that once the passenger got created, we will not change him, right? So we just add him and it's not changeable later on. So this time mutable is absolutely fine, or immutable is totally fine for us. So we don't have to adjust the record later on. So this is why we can leave it as a record. But the flight changes, right? Every time we add a booking, we change the flight object or the flight entity. So this is why we need to take a class instead, or why Microsoft says that we should take a class instead of a record. So if your entity is not changing, you can feel free to go ahead with the record. But if you want to change an entity later on, for example, while it's on delay, remaining number of seats is changing, bookings are changing, right? So the entity type changes, then go ahead and use a class instead, followed by the best practices of Microsoft itself. However, in any scenario, Microsoft prefers to use a class instead of a record. And that makes totally sense because in most of the scenarios, your entities inside of your database are about to change by time. So then you go ahead, change the flight, the passenger has cancelled, or he has just entered the wrong name and you will edit it. But in this application right here, we are not changing the passenger at all. So once you've entered or registered, we are not able to change any information. Great. So let's move to entities again, because we're not done with the mapping yet. So you now have learned how you can use onModelCreating to create a new or how you can set a unique key, and this time it's the email. By default it could be something like public int ID, right? But if you want to go ahead with a non-integer and use the email instead, you know now how you can do that. And we also need to define that a model builder, there we go, dot entity of type flight. Take a look at the flight. We got time, place, departure and arrival, right? So we need to specify, since those two here, they are no primitive data types, right? They are complex data types because it's not a string or an integer. It's a time, place object, which is actually a record with place and date time. So, or string and date time. So it's a complex data model, and we need to allow entity framework, or we need to tell entity framework how to map it or that it should map it. So we go ahead and say model builder entity of type flight, and then we say owns one. It owns one, where we say flight owns departure. We also do that for the arrival. Flight owns one a arrival, and this will, well, put the same, depending really on the database provider, but it will add departure and arrival into the same table, but it will now add departure and arrival to, but it will now add departure and arrival right into our database too. Awesome. So this information needed to be specified. Let's save and hit run again. Our application is now running again. Let's start booking a flight. So I register as a passenger after searching here. 2 remaining seats. Let's book. Let's register. There we go. Now let's log in. Let's book a flight. Let's here book 1 seat. You can see my booking works, but if I change back, search again, you can still see 2 remaining seats. So our information is not saved in the database, right? So every time I book something, every time I search again, it still says 2 remaining seats. So this is intended, and it's totally correct. We don't have an issue inside of our project right now, but we need to add something to really make the changes persisting. So switch back to our project, move. So let me just shut down the application. You can move into your passenger controller and just switch into the register method that we got right here. And as I already said, if you add something, delete something, or change something inside of your database or your entities DB context, you need to save those changes. So go ahead and call entities, there you go, with underscore, right? And then save changes. Very, very important. We don't only have to do that here. So we should now switch over to our second controller. So go to the flight controller, go right into book method we got right here. You can see here flight make booking, right? So this is creating a booking. And after checking if we have a conflict, so here we know everything worked fine because that conflict would return. Here we can say entities.save changes. So here where we add a booking of a flight, we want to save changes too. So let's go ahead, start the application again. Awesome. So let's search for flight. 2 remaining seats. Let's register here. There we go. Log in, search again. Let's book a flight. Let's book 2 seats. Let's book. My booking works. Let's go to home. Search for flight. You can see 0 remaining seats. So now our changes are saved inside of that in-memory database. For sure, if we now restart the application again, American Airlines will again have 2 remaining seats, right? Because it's an in-memory database. So as soon as we shut down the application, the, well, in-memory stuff will get cleared out. That makes sense. But as soon as we switch to SQL later on, everything will persist, even though the application is not running at all. Great, and that's it for this video. See you in the next one.